Toto, I have a feeling we're not in Kansas anymore.
Actually, we're going to do something we have done before. We're going to look at lines or equations of lines, but we're going to look at systems of lines. That means we're going to do more than one at a time. That's how good you're going to be at it. I know you will.
Do you mind telling me what this is all about, mister?
Consider if we graphed two equations. We'll take this one and this one. Really, three things can happen. One is what we have here,
Correct, boy wonder.
that they're parallel. Now, we know these two are parallel even if we didn't see them because they have the same slope. Remember the 2 in front of the x. If that's the same, then they're going to be parallel. Or, what else could happen with two lines? We could have this line, y equals 2x plus 10 halves, and y equals 2x plus 5. Well, what happened there? Well, they're the same line. 10 halves is 5, so that's another possibility, as crazy as it might seem. Two equations could be the same, and they could graph in the same place and be the same line. One other possibility, and that is, if we graph this line and this line,
I'm dangerous. I'm very, very dangerous.
is that they intersect, and that's when it's going to be useful.
Show me the money!
Because if they intersect, there's going to be a place, not like this point that's only on the green line, or this point that's only on the red line. There's going to be a point that's on both lines, the place where they intersect.
Oh, dear. That's too wonderful to be true.
It's going to be pretty wonderful because that point, that pair, is going to fit into both equations.
No, I can't take it. I can't take it, Jerry. It's too much. It's too much.
We're going to find that point by graphing the lines. First, let's do it. To solve a system or find the point of intersection by graphing,
Are you pondering what I'm pondering?
all we're going to do is graph both equations separately, but on the same grid, on the same graph. Then, just find the point where they touch and look at it, and that's the answer.
Believe it or not.
That point where they touch is a solution to both equations, or we say that it's the solution to the system of equations. Let's do one. I'm going to find the pair of x and y, the point that fits into both of these equations, that solves both of them simultaneously by graphing both of them. Well, first let's graph the first one. Y equals 2x minus 1. Remember how to graph. I'm going to make a chart. And I'm going to put in the three easiest numbers I know. If I put in a 0, y will be negative 1. And I graph the point 0, negative 1 by going over none and down 1. Okay. Let's put in another number for x. And we'll put in our next easiest number, 1, for x. And apparently 2 times 1 minus 1 will equal 1. And in that case, x is 1 and y is 1. So I'll graph that point by going over 1 and up 1. I like to do one more, remember. And I'll put in 2. 2 times 2 minus 1 ends up being 3. Say a little prayer that they line up, but I'm going to go over 2 and up 3, and there you go. I know I'm okay because they line up, remember? Okay, but that's not the whole line. That's not all the points that fit in.
To infinity and beyond.
I have to draw the rest of the line. So that's the graph of our first equation.
Now what am I going to do?
Well, now I'm going to graph the second equation on the same grid. Now the second equation is 2y plus 4x equals 8. How do you do that? What did I forget? We always begin graphing a line by solving for y. Let's see, who's keeping y from being alone? The 4x I'll subtract from both sides. And then the 2, I guess he's multiplying, so I'll divide. And I'll get y. There you go, solved for y. Y equals 4 minus 2x. Now, I'll put in some points. Put in some numbers. 0 for x. 4 minus 2 times 0 is 4 minus 0, or 4. So I'll graph the point 0, 4. And then I'll put in the next easiest number, a 1 for x. And 4 minus 2 is 2. So I have the point 1, 2 fits in. Go over 1 and up 2. And maybe one more.
What a dumb thing to do. I bet you wouldn't have done anything like this if Mom and Dad
Put
were
in
here.
easy numbers, okay? Put in 0, 1, and 2.
Nip it in the bud.
Okay? Make life easy on yourself. If I put in a 2, I'm going to get 4 minus 4, or 0. 0 can be an answer. And I will graph the point 2, 0 by going over 2 and up none. And I'll feel pretty good because they line up. And let's draw our line. Well, now, hopefully you can see the solution to this system is the one point where those two lines intersect. The problem is
You're plumb right,
we have to estimate a bit. That's about 1.3, 1.3. But that's about the estimate of what I think would fit into these two equations.
Do that again.
Okay, we're going to do another one, and hopefully you'll see how they're the same. Let me start by graphing the blue equation, y equals 4 minus 2x. Well, I'll put in a 0 for x, and quickly, y will be 4. And I'll graph that point. And I'll put in a 1 for x, and y in that case will be 2. So I'll go over 1 and up 2. And lastly, I'll put in a 2. And I'll get 4 minus 4, or 0. And the point 2, 0 is right there. And I'll have graphed. Well, I'll have to draw the line. And I'll have graphed the first line.
Now what am I going to do?
Now we graph the second line on the same graph. Now the second line,
Brain is gone.
remember, what do we have to do? Well, with both lines, the first one was already solved for y. This one, once again, we can't begin till we solve for y. I'll add 2x and divide everybody by 3. This one's going to be a tough one. If I divide everybody by 3, I'm going to get y equals 4/3 plus 2x over 3. Wow, fractions. That's okay. Let me put in 0, 1, and 2. And if I put in 0, I'll get 2 times 0 over 3. Basically, that's going to wipe out, and I'm going to get 4/3. Now recall that 4/3 is really 1 1/3. So I'm going to go over none and up 1 1/3. Now, if I put in a 1, I'm going to get 4 plus 2 over 3, or 6 over 3, or 2. That's a nice point. I'll go over 1 and up 2. Let me do one more. Put in a 2, and I'll get 4 plus 4/3, or 8/3. Now 8/3, 8/3, 8 divided by 3 is 2 2/3. So I'm going to go over 2 and up 2 2/3. And son of a gun, they line up.
You look marvelous.
And I'll draw the line. And I know
Prepare to be astonished.
the solution that fits into both equations, the common solution to the system y equals 4 minus 2x and 3y minus 2x equals 4 is this point, 1, 2. Now you don't believe me, do you? let's put in a 1 for x and a 2 for y, and son of a gun,
You're absolutely correct.
2 does equal 4 minus 2. 2 does equal 2. It works in the blue equation. What about the green equation? Put a 1 in for x and a 2 in for y. 3 times 2 is 6. Minus 2.
You are correct, sir.
It works, and it's the only pair that works in both.
Yeah, baby. Yeah.
So it's the common solution to the system. That's what it means to be the solution to the system.
Pay attention, son. Look at me when I'm talking
So
to
to
you.
solve a linear system by graphing, we're going to just graph both equations separately as lines on the same graph, and then find the point of intersection,
Believe it or not.
and that point is the solution to the system. Now,
How about a little fire, Scarecrow?
we can do this with a graphing calculator if you want to. But before we do that, remember, we can't graph lines on a calculator unless we solve for y, and that second one we'll have to solve for y. And I promise you it's y equals 4 minus 2x. Now, we had done this problem before, but let's do it with a graphing calculator. Okay, let me turn this baby on. And I'll hit y equals, and I'll type in the first equation, 2, and there's the x button, minus, don't hit the negative, minus 1. And I could hit graph, but you know what? I need to do the second one, so I'm going to cursor down and type in the other one before I hit graph. And the other one is y equals 4 minus 2x. And now I'll hit graph, see it up here? And we'll see both lines. Now what you can do is cursor around. See the cursors? And as I move, hopefully you can see, I'm pointing to it right here, kind of the crosshairs. And I'm going to move my crosshairs onto the intersection. And that'll be our way right now anyway to estimate what that point of intersection is. If you look at the bottom, I have x is about 1.276 and y is 1.29. As we thought before, the intersection is about 1.3, 1.3. Note that we do have to estimate using this method. Okay, let me clear that out. And we're going to try another. Let's try finding the point of intersection of these two with a graphing calculator. I already have it on. I'll hit y equals. I have the old equations in here, so I'm going to have to hit clear to get rid of it. And I'll type in the first one, 2x plus 1. And then I'm going to cursor down to the second one and clear out my old problem and put in my new one. 8 divided by 3 plus 2x, and let's hit graph. Now if I look for the point of intersection, uh-oh, there isn't a point of intersection. Well, guess why there isn't?
There's something screwy around
Oh
here.
yeah, I forgot.
I know that, dude.
If two equations have the same number in front of x, that's the slope. If they have the same slope, they're parallel. So there is no solution, is there? Okay,
Scotty, beat me up.
that'll be enough for today. Go practice your graphing and find those solutions to those systems.